Greetings, Saintsmen. This is lesson 1.6 for geometry, which is describing pairs of angles. We're going to define a bunch of terms today. We're going to go over complementary and supplementary angles. Additionally, we're going to discuss adjacent angles, as well as discuss the vertical angles and then the relationships that these angles have with each other. It's going to be important for us to memorize these. There should be some prior knowledge regarding these ideas, but want to make sure that we have these filed away and we know how to solve problems utilizing these concepts. First thing we're going to take a look at, of course, is going to be a right angle. Again, defined as a right angle because I have that little box that's down here in the corner. From here, I'm going to create a subdivided angle. So I have angles 1 and 2 that are within it. Now, the angle measurement for a right angle, as you know, is 90 degrees. So by definition, angles 1 and 2 are going to be complementary angles. The reason they're complementary is because complementary angles have an angle sum of 90 degrees. So let's write that down. So these guys are complementary angles. And so we know how to suffer through my handwriting. We're going to go ahead and write this down. Complementary angles have a sum of 90 degrees. So again, we know that through angle addition, angle 1 plus angle 2 is going to create that right angle. Right angles have an angle measurement of 90 degrees. Therefore, these angles are complementary. So it doesn't have to be exclusive to angles that are created within a right angle. So for example, let's construct a couple others here. So let's have these two angles not touching each other, of course, right? Just kind of out here in space. We're going to call the one on the left angle 3 and the one on the right angle 4. And angle 3, we're going to say is 30 degrees. And angle 4 is 60 degrees. Okay. Something of note is that angle 3 and 4, read the definition, have a sum of 90 degrees. They're not touching each other, but also these two angles are going to be considered as complementary. All right, so both 1 and 2 are complementary, as well as 3 and 4. So they don't have to necessarily be touching. But the giveaway, 1 and 2, it's a little bit more obvious, right? Because we see the right angle, knowing that's 90 degrees. We have to do a little bit of computation here on 3 and 4. I actually have to add together 30 and 60 to get 90 to confirm that these are complementary angles. Something that we're also going to get into right here is angles 1 and 2. And angles 1 and 2 are what are going to be known as supplementary angles. Now, why or how do we know that? Supplementary angles, by definition, are going to have a degree measurement that's going to be 180 degrees. And these two angles that I have above you, for sure, we're going to talk about that specific instance as to why, when we see those, why those are going to be supplementary always. So 180 degrees, right? So 1 and 2 happen off of a line. We're going to talk about that relationship and what that specifically is, right, for angles 1 and 2 shortly later in the lesson. But when we see this, and we're going to talk about this specific instance, right, where these guys are going to share a side, we don't have an angle measurement that's being given to us for angles 1 and 2. Okay, so on sight, we're seeing that these guys are supplementary. Where we maybe have an easier time with it is, again, as we get into this instance, like let's say we have this angle right here, and then we have, again, it's not connected, but we got an angle right over here. We're going to call them again 3 and 4, but this time angle 3 is going to be equal to 100 degrees. Oops. Well, angle 4 is equal to 80 degrees, right? Which is going to be kind of a slam dunk for us, right? Here's the definition. Angle sum's 180, right? So 100 plus 80 is clearly 180. So we should be able to make that conclusion very simply that angles 3 and 4 are supplementary. Something to note here. We will not have 3 angles be complementary or 3 angles be supplementary. This is only for 2 angles at a time. Okay, so for example, we have these angles up here, 1 and 2. Let's talk about this initial example. Those guys are just 2 angles we're discussing, right? Now, if we had a third angle that was in there, hypothetically right in here, and you'd say, oh yeah, well, those 3 angles are complementary to each other. You can't say that, right? But what you could do is, of course, you could create right here these 2 angles, right, through angle addition, making that larger angle, right, which is in this case angle 2, and then that and 1 would therefore be complementary, right? So we're gonna have to consolidate, right, through angle addition to get the two measurements to get the 90-degree summation. Same thing with supplementary, right? I could take other parts to create something, right? But ultimately, it's going to be 2 sums that are going to make the sum of 180. Okay, to define it as being supplementary. Now, this example up here, and actually even the very first one with complementary angles, showed something that we're going to work with going forward, which is what's known as adjacent angles. And what adjacent angles share is a common side. You have to think about what house is adjacent to yours, or what apartment is adjacent to yours, right? When we're talking about adjacent, and people wonder what that means, well, it's your neighbor, right? For me, who's adjacent is my neighbor Lloyd. Lloyd, wonderful man. He's elderly man, 97 years old. World War II vet. He's I'll tell you guys in class some really funny and awesome Lloyd stories, because he's quite a character. He reminds me of the man from Up with the walker with the tennis balls on the feet of the walker. He's known to walk our neighborhood, sometimes utilizing the middle of the street. Lloyd and I share a fence. That fence a couple years ago fell down, and Lloyd wasn't really aware about that for a few days. When I went over to talk to him about repairing it, I kind of brought it to his attention. So that fence that we share has since been repaired, and that's the thing that we share in common between our 2 properties. So that's what makes him his house adjacent and makes him my neighbor. If you have an apartment, you're going to have somebody who lives adjacent, and you share a wall with them, right? So like in my classroom, Mr. Thompson's room, where we hear kids banging on the wall sometimes. In fact, as you might be watching this video, and hear kids banging on it, or hear kids roaring next door, that's because we share a wall. So there's not that much privacy between the two classrooms. Here, adjacent angles show 2 things. Of course, since they share a common side, that common vertex, right, is a point, because vertices are just points. So right here, this side right here, which is ray BC. Ray BC is the shared side. Okay, and then right here, this point right here, this is the shared vertex. All right. So what we have here, of course, we have, as we discussed before, not 2, but we have 3 angles, right? We have this guy, and then we have this guy, and then we have the bigger one, right? So the angles that are kind of the result of the subdivision of angle ABD, right, which is angle ABC and angles CBD, these two angles are adjacent. They're next door to each other. They share a wall, right? They share a side, which is BC. And of course, they share that vertex. That's B. So you'll hear me utilize that term adjacent quite often as we continue through the course. So now we know what that means. Let's discuss some adjacent and some non-adjacent angles. So let's draw this guy out here. So this is A, B, C. And then we got this guy over here, which is H, J, and K. Right? And then another angle right over here. Oops. Yeah, let's get some points on here. This is point D. This vertex right here is E. This point on this ray is G. Right? And then we have F right here, bottom. And I'm going to give some degree measurements here, okay? So angle ABC is 28 degrees. Angle HJK is 72 degrees. We have angle DEG, which is 108 degrees. And we have angle GEF, which is 62 degrees. So here are our directions. What we're going to do in this exercise is that we're going to name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So I want you to take a moment and see if you can identify complementary angles, supplementary angles, and adjacent angles. There's a pair of each in this example. Now, here's where some people are going to get tripped up here in the class, because some people very simply saw and were triggering from their earlier experience, like, oh yeah, I've got this and this, boom, there it is. Those are my complementary angles, and that is incorrect. Gentlemen, angle ABC is not going to be complementary to HJK, because once you do the addition there, 28 plus 72 is not 90, it's 100, right? This is where you should make sure that you have a calculator out, right? As you did this video or watched this video at the beginning, I hope that what came out was not just your notebook and your pencil, but always needs to be our calculator. I don't know, I have to fight students so much about this anymore. I'm only saying this so they can succeed. I'm only trying to give them all of the advantages, but the students try to impress me with how well they do calculation, which is really silly, because I'm really not that easily impressed, especially since I'm better at it than you are, and I still use a calculator a lot of the time. So it's better to reserve all that thinking power for reasoning rather than for calculation. This is the angle 62 plus 28, right? That's going to give us that sum of 90. So it's ABC and GEF that are adjacent to each other, okay? And then, not adjacent at all, that are complementary, that have that sum of 180. And then we have the supplementary angles, right? So we need to find a sum of 180. In this case, it's going to be HJK. 72 plus 108, DEG. That's going to give us our sum of 180. Now we need the two neighbors, right? The ones that share a side. The adjacent angles, which in this case is going to be angle DEG and GEF. All right, continuing on. Solve another problem. So if angle 5 is a complement of angle 3, and the measurement of angle 3, we talked about that measurement notation before, which just means it's it's that many degrees, so it's 53 degrees. We're going to find the measurement of angle 5. Knowing too that something that's come up is so far that measurement we've worked in degrees. Just like for when you measure length, there's inches and then there's centimeters, right? and they're different, right? It's just a different unit that you can utilize to measure the length of something. There is also for an angle. There are other units of measure, right? A very popular one we will very briefly discuss is called the radian. It's this. You don't need to really. I'm just writing it down so you know what the word is. But a radian. In fact, it's an issue with your calculators that we have to make sure that they're going to output answers that are in degrees rather than radians when we start doing some trigonometry. Yeah, because it's just an entirely different unit of measure. It's a different way to go about things, right? And again, the angle. So people will see this with an angle like ABC, right? And I start to ask about the angle, and people start to say, well, angle AB, and it's like, that doesn't make any sense. That's just a ray. The angle itself is this openness right here, right? And to what degree, like, no pun intended, to what, how much is that opened, and we can measure that in degrees. So 3 and 5 are a complement. Numbers should jump out at you, right? Which means that 3 and 5, or 5 and 3, have a sum. Complement means the sum will be complementary, 90. And now we substitute. We know that 3 is 53. So 53 plus angle 5 is equal to 90. We're going to subtract 53 from both sides. Angle 5 is equal to 37 degrees. And that's your answer. All right, continuing on. We have angles 1 and 2 are supplementary. And we're going to find the measures of the angles when the measure of angle 1 is equal to 7x plus 13, and the measure of angle 2 is equal to 25x plus 7. And let me oops, I'm going to enlarge this for you. Probably want to make sure you guys can read that in the video. Okay, here we go. So again, we have two angles. They're supplementary, when it means that the sum of those two is going to be supplementary, means 180. So now we have these word associations with the number, right? Complementary 90, supplementary 180. Okay. Now we substitute, right? 1 is going to be 7x plus 13. 2 is 25x plus 7. Okay. And then we can actually take a sum here, right? So we have 7x plus 25x, that's 32x. 13 plus 7, right? That's going to be 20. That's all equal to 180. Continuing on, minus 20 on both sides. Cancels out. Kind of off to the races right here, right? Just doing our algebra. We have 32x is equal to 160. To solve for x, get it by itself. I'm going to divide by 32 on both sides. Okay. Just not having to worry about the calculation, right? The important part is that we're performing the procedure correctly because the calculator does this, right? 160 minus 32 is 5. Now, gentlemen, that's not really our answer right here. That's not what it asked for. It wanted us to find the measure of these angles. So we have to go back and think about, well, the measure of angle 1 was 7 times, in this case, x, which we now know is 5, plus 13, or 35 plus 13, which, when we add those two together, we get 48 degrees. And then, of course, there's the measure of angle 2. Same sort of procedure. And you get 25 times 5 plus 7, right? Which is going to be 125 plus 7, or 132. Now, you may be thinking right now, Mr. Granados, there's got to be another way about this, because what you told us is that these guys are supplementary. So the sum is 180, and if we know if we know the measurement of 1 is 48, couldn't we just go and do 180 minus 48 to get the other angle? And of course, that's the case, right? That it's going to work. One thing that I do want you to do is also to consider making sure that you perform this step. You should probably do both things, really, right? You should look at this and say, well, what's 48 plus 132? And that's 180, okay? And then even, right, as another method to check, And then even, as a kind of like a two-step verification, making sure that we go and substitute that value x is equal to 5 and then evaluate the expression to get 132 degrees. So yes, it is possible. It is true. It works. It doesn't really matter to me. But just know that it can be done both ways. I think there's a lot of power to being able to do it both ways. Let's go back and revisit this guy that we talked about at the beginning of this lesson. This has a special name. Again, these were supplementary angles, or these angles are supplementary. But the name of this relationship is what's called a linear pair. I love this. I've told you before, I don't like calling things easy or hard. But what's important is that not so much making that distinction if something's easy or hard, but saying, hey, the definition is in the name, is in the term. This is a pair of angles formed off of a line pair. Okay, these angles are both supplementary and adjacent. 1 and 2 are a linear pair. The reason that they're supplementary is because they are a linear pair. And the reason that they have a sum of 180 degrees, therefore, is because they are supplementary. See what I did there logically? Okay, it's important to find these guys, that 1 and 2 are a linear pair. That's what makes them supplementary, and because they're supplementary, that's what gives them the sum of 180 degrees when we add the two together. Okay, next is the following relationship. All right, these guys are called vertical angles. And these are formed when the sides are two pairs of opposite rays. They are non-adjacent, but they're congruent. Okay, so there's this notion of what is vertical, right? A vertical line is going to be straight up and down, right? The y-axis is the straight up and down line. So this guy right here, 3 and 5, should be the very obvious vertical angles. But I want us to study what 3 and 5 do, how the relationship is, so that we can identify the other pair of vertical angles. I want you to consider this. I didn't have to jump the fence when Lloyd's fence, when our fence fell down, right? And that would be going next door. That's the adjacent angle, right? But what I'm doing here is I'm really kind of jumping over the vertex, right? I'm going over the vertex to this angle that's non-adjacent, to a congruent angle that's 3 and 5. So therefore, check these two out. 6 and 4, or 4 and 6, these two are also vertical angles. Alrighty. My last example for you for today. We have two angles that form a linear pair. The measure of one angle is 8 times the measure of the other angle. So we are going to find the measure of each angle. This is going to be very straightforward, gentlemen. We have angle 1 and angle 2 as a linear pair. Okay, which means they are supplementary, which means that their sum is 180, right? So if I have 1 as some number, the other one is 8 times that. So I have x plus 8x is 180, meaning that 9x is equal to 180, meaning that x is really going to be equal to 20, right? Because I got to divide by 9 on both sides. And there we go. Take this guy, throw it back in there. So we have angle 1 is equal to 20, okay? But angle 2, which is really equal to 8 times 20, or 160. So, there you go, gentlemen. That is today's lesson. Go ahead and get started with the lesson 1.6. The assignment is on Canvas. Good luck.